Hey everyone, welcome back to another video for Quill Academy. So in this video we will be understanding a vulnerability in Solidity that is PRNG attack. It is also referred as weak source of randomness. So PRNG basically refers to pseudo-random number generator. So it's an attack on Solidity. So let's understand it. So what we will be covering is we will be looking at how we can generate random number in Solidity and what is exactly the issue with generating random number, and also we will be practically exploiting this vulnerability in Remix IDE, and also at the end we will be understanding how we can prevent this hack, or how what are the best practices or mitigation against this vulnerability. So let's get started with it, right? Okay, so we have generating random number in Solidity. How we can generate random number in Solidity? So we can use block.timestamp, block hash, block difficulty, block number, block coinbase, all these predefined methods for related to block to generate random number in Solidity, right? So if we look at block.timestamp, it is the current timestamp as second in the Unix, right? Also block hash, we have the hash of a given block. It only works for 256 most recent one, and we have block.difficulty, which has been replaced with prefrando since the VM version Paris, and we have block.number, which tells us the current block number, and Coinbase, so it tells us the address of the miner. So we can use all these methods to generate random number in Solidity. Yes, but how can we actually do it? Let's look at it. So we have a contract over here and a function in which we can generate a random number. So let's look how we will be doing it, how we will be implementing it from scratch. So we have Remix ID. Let me make it a bit large. Yeah. So we have a contract which is we have named it a random. Now let's add a variable rand number. So we have declared a variable rand number, and we will be having two functions. The first one is set number. It will be an external function so that we can call it, and the second one will be get number. It will also be external. It will be view function which will return the set number, which will return the random number, right? So let's make it. So in Solidity we can use keycac 256 to generate random numbers, right? So what we can do is let's assign okay, so we have added the function, and let's do abi.encode. Let's encode the block.timestamp, and let's okay. So what the issue here is, we need to uh, typecast it with uint, because random number is type of uint, right? So we have successfully implemented the function for setnum, which will return the keycac 256 hash of block.timestamp, and it will typecast it to uint and store in random number. So in get number, we will be just returning this value for random number. It's just a getter function. So we have successfully implemented it. We can also add some other variable over here, just like message.sender, or it may be block dot difficulty. So yes, it has been deprecated, but yeah, for this example we can use it. So let's deploy this contract, and we have successfully deployed it. So once we call the set number, it will assign a random number to the rand number, and once we call the get number, it will give us the value, right? So it's a very large number, and if we call it once again, it will change. Every time we call it, it will change to a random value. We can make it customized one using modulus. So if we add modulus 100, then it will return any random number of 2 digits. So let's try with 1000, right? So it will return of 3 digit. So let's deploy it once again, and if we call get number now, we get 860, right? And if we call it once again, we get 641. So we can see that we have successfully implemented the random number generator in Solidity. But wait, this isn't secure at all, right? So let's see what are the issues with it. So here are some issues with generating random number in Solidity. So first of all, Solidity doesn't have built-in function for generating random number. As we saw in the example, right, we are using block.timestamp hash or message.sender to generate the random number using keyhack256 hash, right? So yeah, due to the deterministic character of the blockchain, it's practically like impossible to generate random number in Solidity. The reason is that the blockchain is transparent and everything is predetermined, right? So anyone can predict it earlier, right? So it's not random. So instead it relies on deterministic algorithm. However, this algorithm can be predictable, right? So it can be predictable, it can be manipulated, right? So we cannot rely on Solidity, this block.timestamp and block functions for generating random numbers. So a real life exploit occurred in 2018. It was given a CVE. So if we try to just look at this CVE details, we will find some more details about it. Yeah, so here is a description about this vulnerability, about the incident. So the end flipcoin function and throw slammer function of the smart contract for CryptoGS used old block hash, right? So they used old block hash for generating random number, and the attacker just predicted the random number, and he always won the game. It was assessed a base score of high, which is 7.5. So here are some more detail about it. We can also go to this article for more information on this. We can also go to this article. It explains really well what was actually wrong in the contract and how it was exploited. If we look at this article, yes, we can see that it's very explanatory. And yeah, so let's practically exploit this vulnerability and let's see how we can predict this random number beforehand, right? So this code has been taken from Solidity by example. It's an awesome website for learning Solidity or basics DeFi or some Solidity hacks. So you can move to this website and you can copy this code. So we have the code on the remix. Let me check. Yeah. Okay, so we have this challenge or attack contract, right? So here is the contract, guess the random number, then we have constructor payable, and then we have function guess, right? So it's basically a game where if we if we could guess the correct value for answer, we will get 1 ether as a prize, right? So but the issue here is we can see that it's using block hash and block timestamp to compute the value for answer, right? So we can easily predict it. So yeah, we are computing block hash of previous blocks since because the current block hasn't been mined yet, and the block.timestamp over here is the current timestamp, current Unix time for when the transaction is executed, right? So how we can exploit this contract is we will be pre-computing the hash value, and then we will simply call the guess function for this contract. So we will create an attack contract where we will be pre-computing this value, and then we will be simply calling this vulnerable contract with the value, and we will successfully get one ether, right? So let's create a contract attacker, and let's add a function attack, or let's rename it to exploit. And here we will be taking the contract address for the vulnerable contract. Let's write a for just let's write a, right, and let's name it public. And over here what we can do is we can simply copy paste this thing, right? So because we will be pre-computing, so we can simply copy paste over here. Yeah, so we have it. And the next thing we can do is after pre-computing this value, we can after pre-computing this value we can simply call the function of guess from this guess the random contract address. So we will be just inputting a, and we will be simply calling guess, and then we will be passing the answer what we actually computed over here in this line. And yeah, pretty much everything is done. We will be also creating a helper function to check if we actually won or not, check the balance, right? Let's make it public. View returns uint return address this dot balance. Yeah, we are pretty much done. So okay, one thing we just forgot is receive function. Because it's a smart contract, we need a fallback or receive function to actually receive any ether, right? So let's write receive function external payable. So we are pretty much done with our attack contract, and we can see that it's compiling correctly. So let's deploy our guess the block contract with 1 ether. So we have successfully deployed it, and we have 1 ether balance. And now let's deploy the attacker contract. And what we will be doing is we will be just copying the address for this contract, and we will be just deploying it, and we will be passing that address over here, and we will simply call the exploit. And yes, we can see that we just guessed the correct answer and we won the game, right? So we have successfully gained the balance. So let's look at how can we mitigate this vulnerability, right? So the last part we have is mitigation or preventive techniques. So basically the best practice would be we should not use any block hash or block.timestamp or any attributes of block for the source of randomness. Also there is a channeling VRF which can be used for generating random number off chain. So we can do it. There is an awesome doc from Chainlink on how we can implement Chainlink VRF for generating the random number. You can go through this thing, and yeah, so that is all for this video. Thanks a lot for watching. We will be soon releasing some more videos on Solidity vulnerabilities and DeFi attack vectors. So till then, like, follow and subscribe to Quill Academy. Thanks a lot.